Um, this is going to be a short stream since I've streamed for approximately 8 hours today. I just wanted to finish things that were started in this episode. I found a way to do the icosahedron, at least an approximated version of it. And I also did the index composition in terms of drawing it with lines. Yeah, this is an approximation, and I think I need to play around with the math behind it because this is sort of like the components for a quote-unquote unit icosahedron where the edges should be 1. Hello. Well, did you get notifications? Anyway, this seems to be done, and I actually did a bit of testing. Let me show you how everything turned out. Oh, how nice. So this is the approximation of the sphere mesh collider. As you can see here, it can't go any further than its collider. So that's great. Right now it doesn't check for OBBs, so it can pass through those, but yeah. So now we have a pipeline where we can show debug information in terms of we can do spheres, we can do, let's see, OBBs, and we can do AABBs like these ones. So that means that we actually have all our debugging primitives. What is left is a cleanup of the renderer code, since we completely changed the well, that sounds awesome, man. And I'll do the tutorial tomorrow. Let's see. We clean this up. Then is it still 2D or 3D? So we will actually kind of split this stuff up. We have the initialization stuff. We have the work submission, work updating stuff. Let's actually do this before, I think. Nah. I'll do both. I'll do a localized recording that I will switch on and off, and I'll upload it as a video in parts during the actual live stream, so don't worry. My current bandwidth will support it. All right, let's deprecate all these functions here. We're not gonna use them anymore. Actually, we don't want this one either. So let's clean that up. The live stream will be first. It will be live, but in OBS you can do simultaneous recording. So I'll just upload that while we stream, maybe during breaks or something, or questions, or yeah. All right, we cleaned that one up. Let's see. We don't need this anymore either. We do keep these variables here. We delete this. This is much cleaner now. Now I won't re-upload. Oh yeah, it will be kind of like re-uploading parts of the live stream. I'll just as as an example, I could do a recording of us two talking right now without stopping the stream, and I can toggle that on and off in OBS, and I can upload that video file uh, if needed to. Okay, let's see. We don't want this anymore. We don't want this anymore. We don't. Let's see. We don't need this. None of this. I don't know how we will segment it. I think it depends on. Huh. Did we remove something that we were not supposed to? Okay, maybe we need to move parts of that. Well, this shouldn't be in use anymore. Add, update. No, I think, well, I commented it out and it doesn't claim that there are any errors, so we should be fine. I probably just clipped the wrong parts of the whole thing. Yeah. Okay, so we got that cleaned up. All right, we cleaned that. Um, we would love to swap the last line buffer. Uh, this could be changed, swapped on and off. It's basically the last part of our old pipeline here. Yeah, I'll do that. Yeah, I'll do that later during another episode. All right, let's see. Now we can get rid of all of this stuff here. Since we don't need it anymore. So much stuff commented out. We don't need this either. Let's clean up a lot of this stuff here. New physics. We don't need these packets anymore since we don't use those. We will remove all this old API calls, all these old API calls. I would think so. I would think so. I don't know DirectX 11 at all, so um, but it seems it seems right. Let me just clip out all this old stuff. Okay, this was for rendering the center. Yeah, that seems like a pretty standard pipeline. But I don't know anything about the whole thing that is called device context. There's no such thing in DirectX 11, or rather 12. Therefore, I don't know what it does. But in general, in DirectX 12, you would set up an device and adapter. First of all, of course, a so-called factory, then an adapter, then a device, then you would probably set up a swap chain, and then you would create different pipelines with shader compilation. You would create your different buffers, and yeah, you would upload and bind the buffers to the GPU. and do draw calls, roughly speaking. Let's see. So we've cleaned up this. So now we create our buffers for the debugging stuff. I will have to do a cleanup of the application stuff here later on. Uh, well, the depth stencil doesn't use the Z coordinate as far as I know, unless you actually translate the stuff into 3D space, but I might be wrong. I can't remember. Maybe it does. Actually, I don't know how 2D works in DirectX 11. Well, the depth stencil buffer is kind of a C buffer, so. But yeah, I wouldn't know. Um, all right. Debug mode. We will add a state that is called debug mode. We won't be doing anything in terms of the renderer, but we will make our application control the debug state. So we will do a UI system yeah. I don't know how that works actually. In DirectX 11. Debug mode. And hello, welcome. Uh, Okay, we want to switch here. So if the debug mode is true, we want to set it to false. Otherwise, well, no. No, that doesn't work. Hmm. Let's see if we can find a nice trick. Ah, okay. Sure thing. Good luck, have fun. Let's see. Where do we have an error? Let's see. Render debug item. Maybe we're not done. Oh, okay. All right. Where do we have a problem then? There we go. Something I did forgot to clean up. I think we also could delete this because we have there we go. Okay, so now we can switch debug mode on and off. Let's do a text here. Debug. Plus, let's do debug mode. If it's true, on, otherwise we do off. Am I not allowed to add to a char pointer this way? Maybe if I do a string like this. Let's see. Let's do debug and then debug info. Let's expand the area a bit. We will do this dynamically in the future. We need to. Hello! So now we can toggle debug mode on and off. The last thing we will do is simply Yeah, we should change this in the future. We will simply do something like if debug mode we will do like this. All right. So now we can turn on and off debug information. At runtime. Yeah, we do get several frames extra if we turn them off, but well, that is to be expected. Since we need to do calculations of different primitives. Okay. Let's find where this is defined. We will actually change this to debug point data. So that it primitives. Are you talking about the object parser, the OBJ parser? We don't do any lines. Line prep. Yeah. Maybe you need the face part of the algorithm to be implemented. ABB prep. I'm unsure what you mean by that. Both quads. Debug lines. Debug ABBs. And oh, wait a minute. Maybe I shouldn't delete all this because I do want an example for future use. Render quads. Is your model in quads? Not no, that doesn't make any sense. What Okay, it might be something related to the way that you pass your vertices or indices. It's probably related to the index buffer if your vertices are correct. We do debug AABBs. We do debug OBBs. Yeah, it sounds like a potential indexing problem. Try building a coordinate system in maybe some 3D program and keep on adding your vertices uh, by using the index buffer. Add your vertices to that program. Also be mindful of winding order in terms of primitives because some applications render, like Blender for instance, do models I think counterclockwise like OpenGL, but a lot of DirectX applications are clockwise, so that means that the faces get inverted. So for one, play around with it might be otherwise just try to use your current index buffer and your current set of vertices after you loaded the OBJ model and try to draw the series of vertices manually in another program where you can add points to a 3D space and check out if you draw your faces in the right way. If not, you'll know whether the problem is related to the vertices or the faces and thereby the indices. I can show you a quick example in just a second. So if I have a set of uh, vertices and indices, and we do a coordinate system. This is the C, this is the X, and this is the Y. So if my first index points to a point somewhere out here, I simply draw it. Then I take the next index. Well, if it draws something here, it's fine. And then I take the next index. And if I have a clockwise winding order, this means that this will be a triangle. Yeah, but dump your loaded OBJ information and try to draw out the quads in some kind of render space, or even just in Paint if you are fine with working in coordinate systems like that. It just has to be a 3D space equal to your Z axis. If you have a right-handed sided right-hand sided coordinate system or a left-hand sided coordinate system. Okay, the lines we don't do. Then we do the static objects, static bounding boxes. This should be renamed, but we will do that whenever we maybe we want this instead. We do a debug primitive temp, and we set the temp color to be hello, welcome. And we want to store the. I'm working on my game engine. I'm building a setup for the level editor. And let's do this. Yeah, it's still work in progress, but we're getting there slowly. Let's see. I think this should render all our AABBs. Yeah, we can switch them on and off. Yeah, I used Unity before. I also used Unreal Engine. Did we do padding? I think we did do padding. The padding is in the W component. Then we set the temp position 2 dot alpha channel to be maybe 0. This, and let me just check that everything in the renderer. Yeah, that's nice. Unity is a nice program. I really like it. I also like Unreal Engine, but it's Unreal Engine is a bit more complicated and not as user friendly. Let's see. Okay, we add a bit of padding. Yeah, that's true. Well, okay, now we can easily see our bounding volumes. They don't clip into the let me see. So now every static object has a bounding volume. Yeah. That's the way to go. That's definitely the way to go. Okay. Then we do the OBBs. Let's just do something like this. And do our yeah, that's exactly what you do. And you also need to figure out what you kind of like in terms of game development. Yeah, that's really nice. The whole binding of the UI to the underlying stuff. Yeah, exactly. And we do set. Do we actually? Uh, let's see. This is for the lines. Let's see. Do we do padding here? No, I don't do padding on those. Yeah, are you new to programming or have you done it before? Uh, hmm. Well, it doesn't like that because it's const. Let's do. Yeah, okay. But at least you're not a total newcomer. Then C# would probably be fairly well known to you. Uh, it doesn't like when I const this for some reason, even though it doesn't matter, since we're not gonna change anything. But whatever, man. We will do as you wish. Yeah, that sounds like a great starting point to mess around with game development then. I'm currently at least more of a tinkerer that kind of likes to understand how everything works, and I haven't done much game development yet. I've done some factory building things, uh, and I've messed a bit around with multiplayer, but I haven't really done a proper game yet. So, but I think we will. No, okay. Well, then it's probably not for you then. Let's see. We want to check the spheres here. And we want to add the center. And we want to set the, no, not that. Wait a minute. No, no, that's right. I didn't. Yeah, that seems like a great idea. If you ever get totally hooked by the programming aspect of it, Unreal Engine is probably the next step. Since you're allowed to program in C++. There. Basically, we could do something like the red channel here, sphere radius. We don't need to do that. Whoops. Debug sphere. There we go. Okay. Okay, we need to increase our buffer size, is what DirectX is telling me, but we will do that to make it happy. Yeah, but it also depends on if you like the game development side more than the programming, then you should just stick with whatever you know, unless you're doing something in a very large scale, it won't matter. All right, we do simply now have our debugging system set up. Let's see. Let me turn the camera a bit here. So now we can turn on and off debugging, which is great. That is what I wanted to achieve with this refactoring. So this is basically the end of the stream. Thanks for tuning in if you did that. I will be doing the tutorial stream slash video series tomorrow, sometime afternoon European time. Yeah, maybe I will do some more work on this this engine. Well, it will probably take a long time before it's anywhere near anything that anyone else than myself can use. Um, but yeah, at least I'm having fun. Yeah, hopefully. Thanks for dropping by, and thanks for everyone who hung out with me today. Feel free to comment, like, or subscribe. Follow on Twitch or YouTube for that matter. I do my video archive on YouTube, so be sure to check that out. Yeah, I think we did a lot of good stuff. Oh, before I forget, I promised Karim that I would talk a bit about the material system. Since I've redone a lot of the rendering architecture, the functions kind of like imply what we do during the renderer, and these different elements here will be part of, or at least a lot of them will be part of the tutorial. So that will be a more in-depth walkthrough in terms of DirectX, but we will probably not make a material system. So the way the material system is set up is that we simply create some materials in the application. Materials have these kind of information. Yeah, I think these are not used. So they will be deleted once I clean up stuff. But the most relevant parts of the material stuff is the diffuse albedo, which is basically how much ambient light does the material reflect in RGB and with an alpha value. Next is the Fresnel effect in terms of lighting. It controls specular lighting, and then the roughness determines how rough the surface is, and therefore how much light is reflected in contrast to absorbed, how much is scattered. I think the Fresnel effects. No, this is subsurface scattering. Well, it's normal that different application use. Yeah, yeah, probably. Yeah, it's all down to the model software. Blender uses um the OpenGL way of doing things. So we create these materials. They are at creation time. Well, at least we figured out what the problem was. And then we upload the material data to the renderer, which is done up here. Material preloading. We translate. We create D12 resources for it. It's basically well, it depends of usually I would do back face culling or front face culling depending on your whiting order. But we create buffers for constant buffers for our materials on the upload heap. We transfer the data into something that the renderer can use. It only is interested in the aforementioned yeah, okay, billboards you have to either you have to have a separate pipeline where you don't call the backplane, or otherwise you would have to do billboard processing in the shaders. The problems with billboards are that you would probably experience texture flipping on the opposite side of the billboard. So yeah, billboards are a special case in terms of rendering. Yeah, you basically do some math in terms of um, flipping the parts of the some one of the one or two of the axes of your vertices. Well, you could flip the UV coordinates. I think it's better to just upload the camera position and make sure that you're kind of like always looking at your billboard, and if not, you process. Well, but wouldn't you like the billboard to follow your camera around and always be oriented towards your camera? That's the kind of thing with the billboard, right? It's always centered and correctly angled at your camera. Maybe you want something else, but at least some billboard effects are always oriented to the camera, so the billboard is always shown the correct way, and you will never experience the opposite side of the billboard, and that is because you do coordinate system corrections for each vertex depending on your camera position. Ah, okay. Well, I can show you. at another time what the different effects are. So we translate our material data in terms of the application version of the material data into something that the renderer uh, can use in its pipelines, and we upload that material data for each material to the GPU, and we create a so-called descriptor table for it, where it's like a table over different resources of this type that is placed in a heap where the GPU can access it by getting the pointer to the specific material. So that's the material system. It interacts in the shaders um, during the pixel shader step with different lighting uh, algorithms to kind of decide how much and which kind of light does the object reflect or emit or um, yeah, basically everything you can see is because of light hitting the object and the object actually reflecting light. So the color of the objects are determined on what kind of light they reflect. So a white object reflects all colors of all parts of the light. No, not all parts, but most parts of the light. And a red object only or primarily reflects the red parts of the light. So the material together with the texture and the lights determine how the objects look. Yeah, but I hope that was sufficient, Karim. If you have any further questions, feel free to drop by and make me elaborate or maybe make me talk about something else. Yeah, I'll be ending the stream uh, since I feel like, for one, I've been streaming at least 9 hours today, and secondly, I think I've achieved a lot of the goals that I've set. Currently, for the streams, we have this roadmap uh, planned out, and maybe we can even cross out some stuff here. Uh, More debugging utilities. That's done. That's at least what I wanted. We have done more refactoring. We have done this. Uh, so yeah, that's great. All right. Thanks for everyone who dropped by, interacted during the this. Excuse me, who interacted during the stream and who uh, wanted to discuss different issues in terms of graphics programming or game engine programming. Good luck with your own projects. Hopefully, someone found this helpful. At least maybe some of the viewers found any of the discussions helpful during the streams. Um, Feel free to comment, like, or subscribe on YouTube or follow on Twitch. It's also possible to support the channel if you want to do that. There are links in the description. Also, feel free to join the Discord. Yeah, have a nice one. Thanks for tuning in. Take care.